how to create carboxylic acids the easy way. The answer is to use a Grignard reagent and react it with carbon dioxide, mostly in the form of dry ice. Now, if you know anything about Grignard reagents, you know that you have an alkyl halide mixed with solid magnesium in dry ether. It'll create this thing, which can be treated the same as R, or that same carbon chain, with a lone pair of electrons. That makes it nucleophilic and likely to attack things that have a delta plus charge. Well, carbon dioxide provides us with a carbon with a delta plus charge because it's connected to two electronegative oxygens, which are hungry for electron density and thus delta minus. This carbon looks very, very attractive to this R minus. It's so attractive that it will attack it. No domestic violence involved. And push one of the pi bonds to become a lone pair on the oxygen. Thus, we end up with that carbon connected to the R group. This oxygen double bond to the carbon is unchanged, and this carbon, oxygen, which was double bonded to carbon, is now single bonded to carbon. We already have a carboxylate anion, and all we have to do to convert that to the carboxylic acid is mix it with aqueous acid. That O will gain a proton. It's like a Bronsted-Lowry acid-base reaction, and you end up with RCOOH. It's a beautiful thing. What I do want to emphasize, though, is that if you started with hexyl halide, like a 6-carbon chain here, it is now a 7-carbon chain, and it makes heptanoic acid. You see what I'm getting at there? Let me emphasize what I mean. Let's say we want to create this acid. It is 1, 2, 3, 4, 5, 6 carbons long. You would end up calling it hexanoic acid. Well, you would do that by reacting carbon dioxide, aka dry ice, with a 5-carbon Grignard reagent. Because this is, that's a 4-carbon Grignard reagent. 5 carbons, 1, 2, 3, 4, 5, connected to the Mg and the I. Because those 5 carbons will attack that carbon, which eventually becomes our 6th. The way we create this Grignard reagent is to start with the same length of carbon chain, halide, and the name of that would be 1-iodo-pentane. This is the thing I was trying to emphasize. The halopentane becomes hexanoic acid because the carbon from the carbon dioxide is the 6th in the chain. All right? Pretty easy. I would know how to do this if you have a first-year chemistry exam coming up. And if you don't blame me. All right? Best of luck.